So let's move on to this idea that we built up from in the moles idea, this heart method. How would I use that to do the stoichiometry, like those last two problems in the first several in the problems in the worksheet? Well, the big thing, you're going to have to start from a balanced chemical equation. Let's go back to that benzene example where you burn benzene in oxygen. Benzene is C6H6. And what I would usually do is after I first write out the equation and balance it, and then I would put the gram atomic masses on top of each one because you're always going to need those. Remember when you're going across here, you're going to need that gram atomic mass amount. And so I'll usually do that work up front. 78 grams is the C6H6. Each oxygen is 16, so that's 32 for oxygen. Carbon is 12 plus 32. 12 and 32 is 44. And then each H is 1 plus oxygen is 16, so that's 18 total for those. And so I put those numbers on top just as reminders. And then what I do is, let's take a look at the problem, which says, hey, how many grams of water is produced from burning 156 grams of C6H6? What is given here? The given is the number amount, right? That's over here. So I write that underneath the elements, or the compound of what it's talking about, and then I use the formula to keep myself organized. So this is talking about C6H6. I'm going to write right in here, 156 grams of C6H6. I'm not going to write down the element because it's right underneath this one. As long as I get disciplined to write underneath each one the amount of information that deals with that one, I can get away with not writing C6H6 like I did with the conversion fractions. And I would be disciplined to write those down every time because I do forget, and that definitely causes me to get some errors. So 156 grams here. Now I want to change that. All it's going to do is I'm going to say, oh yeah, I go from what's the unit of the given, which is grams of C6H6, and I'm going to change that to moles. So let's take a peek here. Grams of given to moles of given. I'm going to go against that arrow, which means divide by the gram atomic mass. So I'm going to divide by 78, because it's right there. Well, I chose this because this ends up being 2 moles of C6H6. Now, I'm going to then move from moles of given into what's being asked for, what's wanted. It's asking for water over there. So I'm going to draw an arrow from here to there. If I'm going from 2 to 6, this means that whatever fraction I multiply this 2 by, I got to get a bigger number. So is it, and it's got to be in the same ratio of their coefficients. Is it 6 to 2 or 2 to 6? Well, I got to get a bigger number, so that ratio is actually 6 to 2. And I'll write it right over that arrow. So I know I have to get it bigger by 3 times. 6 halves is just 3. So I'll multiply this by 3, and I'm going to get 6 moles of water. I don't write any more because this is underwater. I know that's 6 moles of water. But it asks how many grams of water is going to be produced. Well, then all I have to do is go back this way. And I say, wow, I got 2 moles of water. What do I need to do? Let's move this down just a little bit. What I have to do from 2 moles of water back to grams of water, I multiply by the gram atomic mass. So let's lift that back up again and say, 6 moles times 18. Well, 6 times 10 is 60, plus 6 times 8 is 48, so that's 108 grams of product water that I need. I find that this way is, for me, the fastest way to do these. Write down what's given, change to what's, always change it immediately into moles of what's given, then look to say, well, what do I want? Change it into moles of what's wanted, and you're going to use some fraction of their coefficients. But reason it out. I'm getting bigger from this one to this one, so I need the fraction that's bigger than 1. And then change that from moles back into grams using my card. And that way, for me, that makes it much faster. If you still like to write down what was given, put a conversion fraction down, 2 moles of C6H6 is 6 moles of water, and work that way, you certainly can. I'm not asking you, but this way for me works quite fast. Hopefully that'll give you a little bit faster, and there's still some problems in the bottom. You can practice using the heart method or stick with what you like if it's the factor label.